Hey guys, today we are going to be talking about isosceles and equilateral triangles and the properties of these triangles. So we're going to start with isosceles triangles. Isosceles triangles have two congruent sides that we call the legs. So here we have BC and AB. So those are your two legs. This is a leg. This is a leg. Okay. The angle where the legs intersect is called the vertex angle. That's right here up at angle 1. You can think about it as what do they have in common? And that's angle 1. The side opposite the vertex is called the base. So if I draw a line from here straight down, from the vertex angle straight down, that is the base. So that is AC. And I can highlight it a different color. The angles along the base are called your base angles. So, this is a base angle, and angle 2 is a base angle. So we can call that angle 2 and angle 3. So we have what we call the isosceles triangle theorem, which tells us that if two sides of a triangle are congruent, so if AB is congruent to BC, then the angles opposite those sides are congruent. Those are your base angles. So then angle 2 is congruent to angle 3. And you can see if I draw a line from each leg straight down, those are your base angles. And those are congruent. The converse of this is also true. And the converse means the flip. So if I flip this around and say if two angles of a triangle, so if angle 2 is congruent to angle 3, then the sides opposite those angles are congruent. Then AB is congruent to BC. This is important. So you may be told, hey, here are two congruent angles, and then you'll have to figure out where the two congruent sides are and go from there. With equilateral triangles, remember that equilateral means all three sides are congruent. And a triangle is equilateral if and only if it is equiangular. So if the measure of angle A equals the measure of angle B equals the measure of angle C, then we can say that AB equals BC equals AC. And the converse of that is true as well. If AB equals BC equals AC, then angle A equals angle B equals angle C. Or sorry, I should put the measures. Oops. Then the measure of angle A equals the measure of angle B equals the measure of angle C. Now let's try this out in some examples. So it asks us to find each measure. This first triangle is isosceles, and I know that because it tells me that these two sides are congruent. These little tick marks, remember, tell me that they are congruent. So because those are congruent, here is one of my base angles, here is the other. So if angle L is 68, angle J is also 68 because these are my base angles. If I want to, I can highlight them. Boom, boom. It is still true that all of the angles in a triangle add up to 180. So in order to find the measure of angle K, I know that 68 plus 68 plus the measure of angle K is equal to 180. 68 plus 68 is 136 plus the measure of angle K equals 180. I'm going to subtract 136 from both sides. And and the measure of angle K is 44 degrees. And you're done. In number 2, you're still dealing with an isosceles triangle. Those two sides are congruent. Therefore, the two angles that you don't know anything about, C and E, are also congruent. So we know that because C and E are the same, in order to find this, we need to do 180 minus 106, which leaves you with 74 degrees. And then because angle C and angle E are congruent, that's the same thing as saying 74 divided by 2, or 37 degrees. And you're done. In number 3, you are given two 60-degree angles. So we're going to start by finding the measure of angle C, which is going to be 180 minus 60 plus 60, the two angles that I know about, which is 180 minus 120, which is 60 degrees. Now, because I know all three of these angles are the same, I therefore know that this is an equilateral triangle. And so because of that, I can very easily say, okay, BC is 9 feet, AC is also 9 feet, because they gave it to me right here. Therefore, all three sides are congruent. Boom, boom, boom. All right, in number 4, they tell me that all three sides are congruent by these tick marks, and then it asks me for the measure of each angle. Well, it's equiangular, which means each of the angles is 60 degrees. Because it's 180 divided by 3, which is 60. All right, now we're going to hop down to number 5, where it asks us to find the value of each variable. Well, they tell us that these two sides are congruent. Boom, boom. And so because that's true, this is an isosceles triangle, which means that these two angles are congruent because I can draw a line straight across and hit these angles, which means that 5x plus 9 equals 8x minus 30 and asks us to find the value of each variable. We're going to subtract 8, I'm not going to subtract 8x, I don't want my x's to be negative. We subtract 5x from both sides. This is going to be 9 equals 8x minus 5x is 3x minus 30. We're going to add 30 to both sides. 30 plus 9 is 39 equals 3x. We divide both sides by 3. And 13 equals x. And you're done. Okay, in number 6, you have these two angles that are 74 degrees, which means that this is an isosceles triangle. And that tells you that these two sides that I can draw straight across from those angles are also congruent. So we can say that 9x minus 73 equals 3x plus 23. We're going to subtract 3x from both sides. 9x minus 3x is 6x minus 73 equals 23. I don't know what that 3 is doing. We're going to add 73 to both sides. (23 plus 73 is 96. We divide by 6 on both sides, and x is equal to 16. And you're done. In number 7, it says that this is an equilateral triangle, so it asks us to solve for x and y. I'm going to solve for x first because it's going to be easier. Because this is an equilateral triangle, I know that each side of that each angle of that triangle is equal to 60. So I can say that 7x minus 3 equals 60. We're going to add 3 to both sides, which means that 7x equals 63. And then we divide both sides by 7, and x is equal to 9. To solve for y, because this is equilateral, you can pick any two sides you want, set them equal to each other. I'm going to use 9y plus 1 and 11y minus 23. You should get the same value for y regardless of which two sides you pick. And if you're not sure, you can double check my work. We're going to subtract 9y from both sides. So then that leaves us with 1 equals 2y minus 23. Oops. We add 23 to both sides. And then you have 24 equals 2y. We divide both sides by 2. And 12 is equal to y. So our final answer is x equals 9 and y equals 12. And you're done. All right, we got 2 more examples here. So if you are not given a picture, I highly recommend that you draw one just so that you can kind of visualize what is going on here. So this is triangle RST. If RT is congruent to ST, the measure of angle R is 9x plus 2. The measure of angle S is 13x minus 18. And the measure of angle T is 17x plus 1. Find the measure of each angle. There are 2 different ways that you can go about this. The first way is that you know that all of the angles in this triangle add up to 180, so you could just add them all together and go from there. Or because you know that RT is congruent to ST, you also know that angle S is congruent to angle R. So that you can say, sorry, that kind of washed it out, that 13x minus 18 is equal to 9x plus 2. Now we need to solve for x. We're going to subtract 9x from both sides, which leaves us with 4x minus 18 equals 2. We add 18 to both sides. So 4x equals 20. Then we divide both sides by 4. And x is equal to 5. So then to find the measure of angle R, we're going to plug in 9 times 5 plus 2. 9 times 5 is 45, plus 2 is 47. Angle R is congruent to angle S, so I can just put 47 right there. And then to find angle T, I can do 17 times 5 plus 1. 17 times 5 is 85, plus 1 is 86. All right, and then last one. That's a bad triangle. In triangle DEF, if angle D is congruent to angle E, so I know that this is congruent to this, which means that F must be up here. DE is x plus 4. EF is 4x minus 8. And DF is 7x minus 35. Find the value of x and the measure of each side. Now, because you're dealing with sides and not angles, you can't just add them all up together and set it equal to 180. You have to figure out where your congruent sides are, which means you have to draw an arrow from your 2 congruent angles to two sides. So you know that 7x minus 35 is equal to 4x minus 8. We're going to subtract 4x from both sides. 7x minus 4x is 3x. So 3x minus 35 equals negative 8. We add 35 to both sides. So that then 3x equals 27. We divide both sides by 3. And x is equal to 9. From there, we're going to just plug in to find DE, EF, and DF. So DE is 9 plus 4, which is 13. EF is 4 times 9 minus 8. 4 times 9 is 36. Minus 8 is 28. And then you can either put that right in for DF, or if you want to confirm that you're good, this is 7 times 9 minus 35. 7 times 9 is 63. I don't know why I wrote minus 8, because that should be minus 35. Is indeed 28. And you're good to go. Head on over, try out your independent practice, and let me know what questions you have. Have a great rest of your day, guys.